A radar detector is an electronic device used by motorists to detect if their speed is being monitored by police or law enforcement using a radar gun. Most radar detectors are used so the driver can reduce the car's speed before being ticketed for speeding. Only Doppler radar-based devices can be detected. Other speed-measuring devices including those using ANPR, piezo sensors, and VASCA technology cannot be detected. LIDAR devices require a different type of sensor, although many modern detectors include LIDAR sensors. Most of today's radar detectors detect signals across a variety of wavelength bands, usually X, K, and Ka. In Europe the Ku band is common as well. Description: one of the technologies that law enforcement agencies can use to measure the speed of a moving vehicle uses Doppler radar to beam a radio wave at the vehicle, and then infer the vehicle's speed by measuring the Doppler effect moderated change in the reflected wave's frequency. Radar guns can be handheld, vehicle-mounted or mounted on a fixed object, such as a traffic signal. Radar detectors use a superheterodyne receiver to detect these electromagnetic emissions from the radar gun, and raise an alarm to notify the motorist when a transmission is detected. False alarms can occur however due to the large number of devices, such as automatic door openers and adaptive automotive cruise control, that operate in the same part of the electromagnetic spectrum as radar guns. In recent years some radar detectors have added GPS technology. This allows users to manually store the locations where police frequently monitor traffic, with the detector sounding an alarm when approaching that location in the future. These detectors also allow users to manually store the coordinates of sites of frequent false alarms, which the GPS-enabled detector will then ignore. Some GPS-enabled detectors can download the GPS coordinates of speed monitoring cameras and read light cameras from the Internet, which are contained in the Trinity database. An interstate traveler could receive an alarm when approaching the location of a speed monitoring camera. Counter technology: radar guns and detectors have evolved alternately over time to counter each other's technology in a form of civilian electronic warfare. For example, as new frequencies have been introduced, radar detectors have initially been blind to them until their technology, too, has been updated. Similarly, the length of time and strength of the transmissions have been lowered to reduce the chance of detection, which in turn has resulted in more sensitive receivers and more sophisticated software counter technology. Lastly, radar detectors may combine other technologies, such as GPS-based technology with a point-of-interest database of known speed trapping locations, into a single device to improve their chances of success. Radar detector detectors equals. The superheterodyne receiver in radar detectors has a local oscillator that radiates slightly, so it is possible to build a radar detector, which detects such emissions. The VG2 interceptor was the first device developed for this purpose, but has since been eclipsed by the Spectre 3. This form of electronic warfare cuts both ways, since detectors use a similar superheterodyne receiver. Many early stealth radar detectors were equipped with a radar detector circuit, which shuts down the main radar receiver when the detector's signal is sensed, thus preventing detection by such equipment. This technique borrows from ALll surveillance countermeasures. In the early 1990s, Belltronics, Incorporated of Ontario, Canada found that the local oscillator frequency of the detector could be altered to be out of the range of the VG2 interceptor. This resulted in detector manufacturers responding by changing their local oscillator frequency. Today, practically every radar detector on the market is immune to the VG2 interceptor. Radar scrambling equals. It is illegal in many countries to sell or possess any products that actively transmit radar signals intended to jam radar equipment. In the United States, actively transmitting on a frequency licensed by the Federal Communications Commission without a license is a violation of FCC regulations, which may be punishable by fines up to $10,000 and/or up to 1 year imprisonment. LIDAR detection. Newer speed detection devices use pulsed laser light, commonly referred to as LIDAR, rather than radio waves. Radar detectors, which detect radio transmissions, are therefore unable to detect the infrared light emitted by LiDAR guns, so a different type of device called a LiDAR detector is required. LiDAR detection, however, is not nearly as effective as radar detection because the output beam is very focused. While radar's radio waves can expand to 85 feet across at 1,000 feet from their source, LiDAR's light beam diffuses to only about 6 feet. Also, a police officer targeting a car will most likely aim for the center mass or headlight of the vehicle and, because radar detectors are mounted on the windshield away from the beam's aim, they may not alert at all. Lastly, with such a focused beam, an officer using a LiDAR gun can target a single car in close proximity to others at ranges of up to 3,000 feet. This has resulted in some manufacturers producing LiDAR jammers. Unlike radar, LiDAR's frequencies and use are not controlled by the FCC. These jammers attempt to confuse police LiDAR into showing no speed on the display. Many times they are successful, and therefore many LiDAR manufacturers are producing LiDAR guns that have jam codes, which show when they are being jammed. They will work on some LiDAR jammers and not others. In spite of this, police can often tell when they are being jammed when they get no reading on their LiDAR. Many jammer-equipped motorists using jammers now try to counter this by reducing their speed to legal limits before they turn their jammer equipment off or kill the equipment referred to as JTK, or jam to kill. Officers can often tell this is going on by just watching for their LiDAR equipment not being able to lock in a speed properly, along with visual indication of sudden deceleration of the targeted vehicle. They will then pull the offending vehicle over and look for LiDAR jammers on the front of the vehicle and can hit the motorist with an obstruction of justice charge should they be found. Some states also have laws about any police radar or LiDAR jamming. These are CA, UT, Company, OK, TX, MN, ALll, TN, VA, SC. In these states the penalties can be severe. Despite the advent of LiDAR speed detection, radar remains more prevalent because of its lower price relative to LiDAR equipment and the amount of radar equipment already in service. In addition, in order to use LiDAR, the officer must be stationary and cannot be moving at all on account of the need for a very precise aim. Legality: using or possessing a radar detector or jammer is illegal in certain countries, and it may result in fines, seizure of the device, or both. These prohibitions generally are introduced under the premise that a driver who uses a radar detector will pose a greater risk of accident than a driver who does not. The table below provides information about laws regarding radar detectors in particular nations. In 1967, devices to warn drivers of radar speed traps were being manufactured in the United Kingdom. They were deemed illegal under the Wireless Telegraphy Act 1949. See also, road safety, traffic enforcement camera, laser jammer. References